Okay, so what we're going to do today is talk about how to figure out whether a function is going to be called even or odd. And there are three different ways to do this, just depending on what you're given. So if you're given a function, you can either look at it with a substitution method, which is the easiest, I think, or we can look at it algebraically. So let's do numeric first. So basically, what's going to happen is we're going to take this function and we're going to say that if we plug in a number here, an even number and an odd number, and they're the same exact solution, then it's going to be an even function. So we're going to do this by plugging in 2 and negative 2. So all we're going to do is take this and say negative 3x squared plus 4. We're going to plug in a positive 2. We're also going to do this and plug in a negative 2. So you're gonna take that and type it in your calculator. So let me get the calculator pulled up. So negative 3, make sure you put the parentheses, they're important, times 2 squared plus 4. You get your answer. And then we do the same thing, but now we do it with negative 2. So negative 3, parentheses, negative 2 squared plus 4. We get negative 8 for both of those, which means it's an even function. Now let's look at what this would mean for an odd function. So we're going to do the same kind of process for odd functions. We're still going to plug in the same numbers. We're going to plug in opposite numbers. We're just going to choose 2 and negative 2. For odd functions, your solutions are going to be opposites. So we're going to say 2x to the third minus 4x, 2x to the third minus 4x. And we're going to plug in 2 here. We're going to plug in negative 2 here. Go back to your calculator. So 2 parentheses 2 to the third power minus 4 times 2 is 8. Then we're going to do this with negative 2. If these are odd functions, forgot to press the over button. If these are odd functions, then we should get negative 8 here. So we get 8 and negative 8. So over here, we'll say this is 8, and this is negative 8. So that proves that these are odd. The last thing we have is going to be neither. So we're still plugging in opposite numbers. So we have 4x minus 2. We can still plug in 2 and negative 2. You type that into your calculator. So we get 6 and negative 10. Since those are not opposites or the same, that is called an odd function. The other way that we can decide whether something's even or odd is by looking at the actual equation. So if we are looking at f of x equals x squared plus 1, we're looking at this part of our equation, and we're trying to see if that function has exponents that are all even. So even functions have all exponents of the function are even. So remember this constant exponent, x to the power of 0 is 1. So that's what that would mean. This one might be a little bit trickier than just substituting it in to find your same or opposite answers. So for odd functions, all of the exponents are going to be odd. So if you look at this function, this exponent is 3. This exponent is 1, which are both odd numbers. So this is an odd function. The last one is going to be obviously neither. So all of the exponents are a combination. So they can either be even or they can be odd. So here we have an exponent of 2, and here we have an exponent of 1. One of those is odd, one of those is even. So this is neither an even nor an odd function. The last way you're going to be able to tell is by looking at a graph. And remember, if you have a table, you can always put that table into your calculator and it'll graph it for you. So if you look at your graph, if it's an even function, your function is going to be symmetric. But it's going to be symmetric across the y-axis. What that means is that this point reflects across the y-axis to here. So your y value is going to stay the same. So your y value is 2 here, your y value is 2 here. But your x value is going to flip signs. So it'll be a negative x and the same y value. So you have x comma y, it's going to flip to negative x comma y. So if we have 3, 3, that's going to flip and be negative 3, 3. That's how we know it's symmetric across the y-axis. For your odd functions, it's a little bit harder to see on a graph. It has rotational symmetry, which means you can take the graph and flip it, like you can rotate it. So if you rotate this graph 180 degrees, that means you're flipping it upside down, basically. If you can take this graph and rotate it around the origin, and it still looks exactly the same, then that's going to be an odd function. An easier way to maybe see this would be that your x and your y values can flip signs and it'll still be a point on the graph. So let's say we have, what is this? Negative 2, 2. So if we have negative 2, positive 2 as a point, if those flip signs, that would be 2, negative 2, which is right here. Since that's still a point on the graph, those are odd functions. The last type is neither, and that just means that it's not symmetric across the y-axis, and it doesn't have 180 degrees rotational symmetry around the origin. Okay, so on the back, you have some examples here. I want you to go ahead and practice those examples now and see what you come up with, and then watch the next video to check your answers.